Okay, you can see what we have today. In this inter-science physics, a branch of the inter-science, and today we are going to tackle on the topic forces. Yeah, and the one taking you today is Sir Daniel. Okay, basically the lesson overview today, we'll be learning about the definition of a force, the types of force, the effects of force, and some mathematical expression of what forces. And after this lesson, the learning objectives are you should be able to define what a force is, the effect of force, application of forces in our everyday life, and how to apply the force in hot calculation when given a equation. Okay, so okay, a force is anything which causes a stationary. Force is anything which causes a stationary body to move or causes a body in motion to stop or changes or the speed and causes the change in dimension of a body. All these things are what the properties of what forces. When you introduce a force to an object, what happens is that when the object is stationary, the object begins to move. For example, if you have a car parked and it's not moving, and 5 boys are at the back of the car, what happens? When they push the car begins to move because a force is being applied to the car. So a force causes a stationary body to move. Also, I said that it causes a body in motion to stop. For example, when a ball is rolling on the ground, when you stop it with your leg, what happens is automatically stays at that point. It doesn't move again. So a ball in motion can be stopped just by your leg because a force is being applied to stop the ball. And it can also change the speed and cause a change in dimension of a body. Change in dimension. For example, if you blow an air into a balloon right now, the size of the balloon is going to change. The size is the dimension of that balloon. It's changing the size and the dimension. And also, when a ball is already moving and you kick it again or you apply an external force again to it, the speed increases because you've attached another force to the existing speed. So the ball was rolling at with a speed, and you've applied an external force to it again. So it's going to increase its speed. So a force also changes the speed, and it changes the dimension. This is basically what a force is. People usually say a force is a push or a pull. I don't accept that. Yeah. So you have to use the properties in defining what a force is. All right. You are moving to the types of forces. The first one you have on your screen is the electrostatic force. Electrostatic force is a force that exists between two charged bodies that are being placed near each other. And as you can see on your screen, to calculate for the electrostatic force, F is equal to the F over there is the electrostatic force. It represents the electrostatic force. You know, force is represented by the symbol F. F equals Q1 times Q2 all over 4 pi epsilon naught R square. The R there is the distance between the two charged bodies, as noted over there. And the epsilon naught is the permittivity of free space. Permittivity of free space simply means the charge is going to move through a given space. For it to for them to react with each other, there must be a permittivity. So the permittivity of free space over there is to permit the charges to react with each other. So it's hot, a constant. And over there, the Q1 is the charge of the first body, and the Q2 is the charge of the second body. That's just the formula for the electrostatic hot force. The second force over there you see is the magnetic force. Magnetic force. This is the force between a magnet and other magnetic hot materials. A magnet either attracts or repels, depending on which material is being brought to. Okay, magnetic force is either attraction or repulsion based on the arrangement of the poles. Poles in magnets simply means either the North Pole or the South Pole. The North Pole or the South Pole. When North Pole is brought near a North Pole, what happens? They repel. When the North and South are being brought together, what happens to it? They attract each other. Like poles repel, unlike poles they attract. So when you continue the slide, a magnet is used in the construction of freezer doors. Okay, we have our freezer doors in the house, the freezers we have in the house, the doors are made of magnets. And it's also used to separate a magnetic material from non-magnetic materials. That's when you put iron filings, let's say you place it in a soil right now, to separate the iron filing from the soil. What happens? You have to bring a magnet near it. If you bring them, yes, hello.
I think you're rushing too much.
Okay, okay, okay. Thank you very much for your notification. Let me take it over again. Okay, the first force over there is the electrostatic force. Hope you all can hear me. Please unmute and hello.
Yes, sir. Yes,
Yes,
sir.
sir.
Hey,
Yes, sir.
wow.
Zungu. Yes, sir.
All right, all right.
Yes, sir.
Unmute yourself, then let me talk, okay?
Okay.
All right. As I was saying, the first force over there you can see on your screen is electrostatic force. Okay. Static means stationary. Okay. So, and it's also called the Coulombic force. Coulombic simply means Coulomb is the unit for charge. So since it's the force between two charge bodies, it's also known as Coulombic force. Okay. So the first force is electrostatic force. And I was saying that this is the force that exists between two bodies carrying charges, as the name goes, Coulombic force. So if you bring two charged bodies together, there's going to be a force of which is going to act between these two bodies. And I've written the formula there to calculate for electrostatic force. And as you can see in the formula, we have F equals the Q1 times Q2 all over 4 pi epsilon naught R squared. The R there is the distance. I've written them over there. R is the distance between the two charged bodies. The Q1 over there is the charge of body body 1. Q2 is the charge of body 2. And the epsilon naught over there, something like E, we call it epsilon naught, is the permittivity of free space. Okay, it's a constant. Okay, when we go on, I said the second force over there is magnetic force. And as for magnets, we know that magnets, they either attract or repel each other depending on the pole being placed by each other. Okay, for example, if I have this as my magnet and I have this as my other magnet, if I want them to attract, I must bring a north pole to a south pole. Okay, this must be north, this must have the south pole before they can both attract each other. Okay, but if they'll repel if you bring two like poles together. For example, if you bring a north pole near a north pole, they repel each other. Or if you bring a south pole near a south pole, they repel each other. So it must always be unlike poles being brought together for attraction to occur. Okay, as you can see in the note, I said this is the force between a magnet and other hot magnetic materials. So that means if you bring a magnet near non-magnetic material, there's not going to be any hot reaction between them. And continuing the slide, magnetic force is either hot attraction or repulsion based on the arrangement of the poles. Pole simply means we have two poles, which is hot, the north and hot, the south pole, the north pole and the south pole. And attraction only occurs at the poles. So if you bring this, let's say you bring in near another magnet, attraction is not going to occur at the middle. It's going to occur at the poles, either the north or hot, the south. So if you bring in near this, they are going to attract to this. Let's say this is ion filing. This is my magnet. If I bring the ion filings near this magnet, they are going to attract at the poles of the magnet. That's where the force is greater. So the force of a magnet is greater at its poles. And I was saying some uses of the magnet. I say it's used in the construction of freezer doors. You have your freezer doors in the house. The doors don't just close on its own. It's by the use of a magnet. And the second one over there is to separate a magnetic material from non-magnetic materials. Let's say if you want to separate, let's say you are coming to use an iron filing in doing some work. Okay, and the iron filing, it fell in the soil right now. How are you going to separate the iron filing from the soil particles? You have to use a magnet to separate them. So it's used to separate magnetic materials from non-magnetic materials. The other force over there also is centripetal force. And this is the force which helps a body to move in a circular path. And it is directed towards the center of the circular path. So this is the force which occurs when a body is negotiating a circular path and is directed towards the center of the circular path. With this definition of centripetal force, can anybody give me an example of a centripetal force? Hello? Hello? Yeah,
Sir,
yeah.
a
Seke.
car going around the roundabout.
A car going around the roundabout. Which roundabout?
I go somewhere roundabout.
Okay, that's correct. A car negotiating a curve or going roundabout, as you said. Okay, any other? Yes. Agbuche, Cindy, Science 1.
Sir,
Yeah, give me one example or application of centripetal force.
okay,
Yeah.
okay.
Uh-huh.
Sir, a planet moving in its orbit around the sun.
Okay, it's correct. It's
Hello,
correct.
sir,
Yeah,
sir.
yeah, I'm hearing you.
Mommy says she's
Hello? Okay.
Hey.
Oh, yeah. I'm hearing you, Cindy. Okay,
I said
Sarah.
a planet moving in its orbit around the sun.
Yeah, it's correct. It's correct. Okay. Thank you very much.
sir,
Yeah. Sarah.
the moon orbiting the earth.
The moon orbiting the earth. Correct. That's good. Excellent.
That's good.
Any other?
That's it.
Please, if you want to answer, raise your hand. Let me call you, okay? Don't just unmute yourself. Okay, let me call the last person. Stephanie, MFA. Stephanie, are you there?
Sir.
Stephanie, yeah, give me one example. Or you have no idea?
Sir.
Yeah? I'm listening. Okay. You, thank you very
There's
much.
no idea.
Okay, thank you very much. Okay, then let's continue with the slide. Some applications are, it helps a car to negotiate a bend. It helps a car to negotiate a bend. That's one application of the centripetal force. So if a car is negotiating a bend, you see that it's moving in sort of a circular hot form and is directed towards the center. And it also helps the earth to move around the sun. It helps the earth to move around the sun. And the last one is it helps electrons to move around the nucleus. Helps electrons to move around the nucleus. Okay, so these are some of the applications of the centripetal force. So my assignment number one is, when we come next time, I will inspect each and every one. Please go and look for more applications of centripetal force. Thank you. All right, then we are going on with tension. Tension. Tension usually occurs in hot spring or stretch hot bodies. For example, let's say this is my spring. If I compress this spring right now, it will come back to hot. It will try to restore its original position back. If I compress this spring right now, it will try to restore its original position back. The force that helps it to restore that position back, or making it to behave as if it's restoring the position back, that force, we call it the tension. So the tension is a restoring force. Restoring force. That means if you compress, let's say, this paper right now, then it's moving back to its original position. The force that helps it to move back to its original position, we call it tension. Okay? All right. And we have the weight. Weight. Weight, it is the Earth's gravitational force acting on a body. The Earth's gravitational force acting on a body. Okay. Someone will ask why the Earth is circular in nature or spherical in nature, and we are still on it without falling. There is a force of gravity keeping us on the Earth's surface. And due to that force of gravity, there is going to be a weight. As you can see in the formula over there, I said weight is equal to the mass of the body times the acceleration due to gravity. So you can see that someone will be is spherical, someone will be here, but still be on the surface of the ground without falling, because of the weight or the Earth's gravitational force is acting on that body. So weight is simply or mathematically it can be expressed as the product of the mass of a body and its acceleration. That's the acceleration due to gravity. So for example, let's say you have a mass of 50 kilogram. You have a mass of 50 kilogram. What to be the weight of that 50 kilogram on the Earth's surface? You just multiply the 50 by 10. The acceleration due to gravity G is equal to 10. It's constant. 10 meters per second square is 10. So anytime you want to get the weight of a body, you just multiply the mass of the body by what? 10. So let's say this paper is having a mass of what? 5. It's having a mass of 5. You want to determine the weight of this paper. How do you have to do? You just multiply the mass, which is what? 5 by what? 10. So the weight of the paper is going to be what? 50 what? Newton. The unit of weight is what? Newton. So simply, the weight is what? The Earth's gravitational force acting on a body. And it's represented by W equals what? mg. M is for the mass of the body. G is what? Acceleration due to gravity. W is what? The weight. And as I was saying, if you have a mass of 5, what's going to be the weight of that mass of the body, or what's going to be the weight of that body? It's going to be 5 times what? 10. It's going to be 5 times 10, which is going to be what? 50. 50 Newton. Don't forget the unit of what? Weight is what? Measured in Newton. Mass is measured in what? Kilogram. Okay. We also have a force called the dissipative force. Dissipative force. This is the force that is capable of producing heat. This is the force that is capable of what? Producing heat. So any force that produces heat, we call it what? Dissipative. Dissipative what? Force. An example is what? Friction. We'll come to that. So the next one will come to what? The frictional force. Frictional force, which we said was what? A dissipative force, because friction produces what? Heat. So what's frictional force? Okay. This is the force that prevents two bodies in contact sliding over what? Each other. Let me do some demonstration right now. If you want this to move on this smoothly, what must happen? You must what? Smoothing this hot ruler, or you must make the ruler hot smooth for it to what? Move. But when it becomes very rough, this can never move smoothly on hot the ruler. The force that is preventing this from moving smoothly on hot the rough road, which is the ruler, the rough part, the force that is preventing it from moving, we call it hot the frictional hot force. This wants to hot, it wants to hot move fast, but hot there is a force that is preventing it from hot moving fast, because here is not hot smooth. So to what? To reduce friction, we hot with smoothing hot the surface. If you're smoothing this surface right now, this can hot move very hot fast. It can move very fast. But when it's rough, it's going to hot. There's hot a preventive force. Frictional force can also be called a preventive force. It preventing hot this from hot moving hot fast on hot this hot road, because the road is hot, very hot, rough. So I'll pause here and ask the house, what are some of the effects of hot friction? Since hot friction produces heat, as I've said in hot, under hot the dissipative force, that is any force that produces hot heat. And we said friction produces hot heat. And we said friction itself is a preventive force. Two bodies is a force that prevents one body from hot sliding over hot another. So I'll pause here and I'll ask the house, what are some of the effects of hot friction? What are some of the effects of hot friction? If you know it, then you raise your hand. Okay, Seriam. Seriam, I've seen your hand. Yeah.
Please wait here.
Wear and tear of what? If you say wear and tear of what? Because it's two bodies that are in contact.
Of objects.
So, of objects. So you can say of objects
Yes.
in contact. The contact must be there. If they are not in contact, then there's not going to be any hot wear and tear. Do you understand?
Okay.
the contact
Yes, sir.
must be added to it. Do you get it? Okay, Peggy. Serian, please mute yourself. Peggy. Yes.
It causes people to move without falling.
Okay. Okay. So that's some of the advantages of hot friction. It
Yeah.
causes people to move without hot falling. Yeah, it's one of the advantage. Because when the ground is very smooth and you are walking on it, what's going to happen? You skid off or you hot fall. So to prevent that, the ground surface must be hot, very rough. Or that's why your slippers is hot. It's not made, the under is not made to be hot, smooth. Because if the under is made to be hot, that's slippery or smooth, you easily hot fall. Any other person? Hello. Justin Jamesi, Science One.
Sir,
Yeah.
sir,
You are unable to.
Is it
I'm
Justin or
mentioning an
Justin?
advantage.
Advantage.
Justin.
Justin, okay.
Yes,
Thank you.
please. Please, it makes the movement of cars
That is
possible.
not correct. It's the put of control classes.
It makes what?
So that's
Movement of
The
cars.
motion of
ask for the meeting
possible.
you put the admin
Possible.
there and put the password in there.
Yes, please.
What makes that movement possible?
Friction.
Hello?
Friction. You can,
See what I said?
Yes,
if
please.
you are giving the example, like elaborate it very well. Like you see that
You downloaded
the
Zoom app
surface
application
of the
on
tie,
or your machine.
Yes, please.
is
So you
very
want to
rough.
join, correct?
You see, it's very rough.
Mm.
And you put in the meeting ID.
That's why if the surface of the tie wears off, you have to hot change it because it can easily hot
Okay.
burst. So it's very rough
Oh.
to
Where are you
reduce
calling?
hot friction.
Where are you located at?
Okay. Okay.
You should not have a
Okay.
problem at all. All your
Right.
colleagues are in class.
Yes, sir.
Yeah. So you can attach the
The
surface
meeting
of
ID
the
is
car
correct.
to it,
Okay?
the tires of the car.
Right.
Car. Okay.
Yeah,
Okay.
the tires of the car.
Mm.
So it's correct. Your answer is correct. You said it prevents hot. Hello?
Yeah.
Yeah. So your answer is correct, okay?
Hello, what
Okay.
Yeah.
Okay.
Fiati.
Michael.
Sir,
Yeah, Fiati.
it helps sharpening of objects possible.
Okay. It helps hot. It helps us to
Sharpening of
sharpen
objects.
our objects. Okay, okay, it's correct. It's correct. It's correct. Because if you want to sharpen your hot, let's say cutlass, you need a rough surface for you to hot, sharpen it. If the surface is smooth, you can't achieve hot your goal. Okay, so it makes sharpening of objects hot possible. Okay, easy.
Sir, please, can you say that friction produces noise in any operation? So,
You said?
can you say that friction produces noise in any operation?
It's true though, but it's not a concrete hot reason or a concrete answer to what I'm asking. Yeah, but it produces noise though. Yeah, yeah. Any other? Hello. I have a whole house here. Oh. Okay, let me call someone again. Avugla Richard. Avugla Richard. Science One. Unmute yourself and
Sir,
yeah.
causes it helps to move objects on the ground
It helps to move objects
or
on
to
the
pull.
ground. Okay. Is it an advantage or disadvantage or what? Or effect or which one? Hello?
Advantage.
Advantage. Okay.
Yes, sir.
Okay. Yeah, Desmond. Yes, Desmond. Yeah, Desmond.
Sir,
Yeah, I'm hearing you, Desmond.
sir, please can you say it helps a match, safety match?
Safety match.
Yeah, like matches.
Ah, oh yeah, yeah. Okay. Hey, your answers are there are some way. Mm, okay. Yeah, Eugene, science.
The causes loss in power.
It causes what?
Loss in power.
Loss in power. Okay. You know, if you are calculating for power and there is friction or heat in the system, or you can say it reduces the efficiency of what a machine. It reduces the efficiency of what a machine. The way you want a machine to work, let's say the machine is having a rotor. Rotor means a rotating part. For example, if you take your electric motor, it's having a rotating part. So when it's rotating, and you use it for a very long period of time, what happens is that it wears out off. So the efficiency, how you want it to work, to not work out very effectively. It will not work very effectively as what you expected. Do you get it? So you can say what you said. You should have said what it reduces the efficiency of what the machine. Okay. Hello, Atta.
Sir,
Yeah, I'm saying that
sir.
you should have said it reduces the efficiency. Oh,
Okay,
okay.
okay,
Of the machine. Okay. Please mute
okay.
yourself.
Yes,
I
sir.
saw your listening. Okay. Okay. Then let's continue. Okay, we have another force called the cohesion. Cohesion. Cohesion is a force of attraction between atoms or molecules of the same hot element. Is the force of attraction between atoms or molecules of what? The same hot element. An example is mercury in hot, a glass. Mercury in hot, a glass. You see, such elements don't hot cling to hot the walls of hot, the different hot element, or they don't clinch onto hot the different hot elements. What happens if you put a mercury in hot, a glass? What happens is that because of hot, the cohesion force, mercury contains that element that hot, makes it hot, not too hot. Mercury contains that element not too hot, make it clinch onto hot different hot elements because it's hot. It's having a force of hot cohesion. For example, if you pour mercury into hot, let's say this is my glass. If you pour mercury into this, right now, what happens is that mercury doesn't hot clinch to the walls of this glass. Yeah, you can see. Yeah. Mercury cannot hot clinch to the walls of the glass. So what happens is that you see it curving inside it. Let me do a demonstration. Okay, a minute. So let's say this is my glass. If you pour mercury into this glass, mercury does not react with what the walls of this glass. Mercury can only react with what its components hot called mercury or another element of the same hot kind. But the walls of this glass is not having the same element as that of the mercury. So you see that there's going to be a separation at the surface. You see the mercury hot leaving that surface, leaving a gap in between hot, the glass and hot. the mercury surface. So it doesn't react with what the walls of what the glass. There's going to be a big separation in between the mercury and what the glass, because they are not reacting. They are having different hot elements. They are having different elements. And we also have another force over there called the adhesion. Adhesion is the attraction between atoms or molecules of different elements. That one, they are, if they are different, they still hot come together. There is hot, just like a husband and a wife. They are of different elements, but hot, they still hot come together. Yeah, that's what adhesion. Adhesion, even though they are of different elements, they still hot react with what each other. An example is what water in hot a glass. Water in a glass. See that if you pour water into hot, let's say this is my glass. If you pour water into it, what happens is that the water clings to hot the walls of hot the glass. You see some particles of water hot on hot the surface of hot the glass, clinging to hot the walls of hot this glass, which makes it that you, because of hot the force of hot adhesion, there's reaction between hot the water particles and that of hot the glass hot the particles used in hot making hot in the glass. So there's hot the force, there's, though they are of different elements, there's force of hot attraction between hot them. So no matter how different they are, there's still force of hot attraction. If you pour water into a container and you pour it out, you see that some water particles still remain in hot the container. This is due to hot adhesion. But if you come to the cohesion, if they are not the same element, or they are if they are of different elements, that one they are not going to hot react. They must be of hot the same hot element. They must be of the same element. So the cohesion is hot. The water poured in a mercury poured in hot a glass, and if you come to the adhesion, is hot water poured in a glass, because water clings to hot the walls of hot the glass. They react, though they are of hot different hot elements. So some of the effects of forces, as I mentioned earlier, effects of hot forces. We said a force causes the change in shape.
Sir,
Yeah.
so under adhesion, can
Yeah.
you consider oil in glass?
Hello? Yeah.
Can you consider oil in glass under adhesion?
Adhesion.
Yeah.
Can you consider hot?
Oil
Oh,
in glass.
yeah. It also clings to the walls of the glass, right? So any particle
Yeah.
at all, or any liquid that clings to the walls of the glass is hot. It possesses hot, a force of hot adhesion. Do you get it?
Yes, sir.
Yeah, please mute yourself. So we are moving on to the hot effects of hot forces on objects. Okay. The first one over there is hot. It changes the shape of hot a body. It changes a shape of hot a body. Changes the shape of a body. For example, let's say this is hot. My body, what happens? It will still remain at this point. But if I hot apply a force to it, what happens to it? If I apply a force, you see that hot, the shape hot has hot changed because of the force hot have applied hot to this. So a force applied to an object can change hot the shape of hot a body. It can change the shape of a body. An example again is what? A balloon. If you take a balloon right now, if you blow air into it, what happens? The shape hot changes. The shape hot changes. So a force changes the shape of what? A body. Another one is called the car tire. The car tire. It also causes what? A stationary body or a body at rest to move. Anytime they say stationary, it still means a body hot at rest. In physics, if they say a body is at rest, that means the body is hot, not moving. It's just like a human being resting. That means he's hot, stationary. He's at one place, either sleeping or just hot at one place. So a body at rest is a body which is hot, not moving. A body, that means the body is hot, stationary. It's immobile. Okay, so this body will still be here. It will not move unless I push it for it to hot move. If you don't push it, it will still hot remain at hot rest. It will still remain at rest. So if a body is stationary or a body is at rest, it will only move when a force is hot applied hot to it. When a force is applied to it. It's also hot. It also changes the direction of what a body, a moving body. It also changes the direction of what a moving body. It changes the direction of a moving body. Okay. If this is moving in this way and I push it like this, what happens? It begins to what? Move in the direction in which what I've pushed it. So you've changed the direction of what this moving body. It was moving in this way, and I apply the force in hot towards hot my front like this. It begins to move in that direction in which of our hot pushed is. So the body hot changes hot the direction of what the force changes the direction of what a moving body. The body will continue moving in that same direction unless an external force is being applied to it for it to what change direction. If a ball is rolling on the ground, let's say a striker passes to what a defender. Okay, for the defender to what change the direction of the ball, he must what play it hot outside, or he must play it to what to another player else for it to be sent away from what the. So it's they are all applying force to what to that spherical object. That's what the ball. So the ball will only change direction when it's hot. A force is hot being applied to it. An example again is when you throw a ball to hit a wall right now, it bounces back to you, right? That means the wall hot has changed the direction of the ball. The wall is acting as a force, an external force, which hits the ball in your hot direction. Another one is it changes the dimension. In dimension, we are talking about the length, the breadth, the width, and all those sort of things. Okay, so when you apply a force to an object, I said a spherical object, if you pump air into it, it changes the dimension. It becomes bigger. Or let's say if you take a hollow object which is cylindrical in shape and you pump air into it, and it can expand, the dimension will automatically change where air is being pumped into it. Another one also is it causes a moving body to stop. It causes a moving body to stop. This body will continue in motion. It will continue to move. So far as let's say the a force is being applied to it, to continue to move. But to let it stop, and opposite force must act to it.
Yes.
There must be an opposite force which will act to the object for it to stop motion. Hey, I can hear someone. Hello? A minute, please. So basically, a force changing the shape of a body, it causes a stationary body or a body at rest to move. So anytime you hear at rest at any place, it means the body is stationary. Note that. It changes the direction of a moving body. It changes the dimension of a body, the dimension, the length, the breadth, it changes or the dimension of what a body. That's if you use hammer to hit a nail right now, the dimension of the nail will change. If the nail is what a weak nail, let's say it has loose hot its strength, what happens? You see that it begins to hot move in certain direction. It tilts. So it changes or the dimension of what a body. It causes a moving body to also stop. When a ball is moving, it will cause it to stop. If you stop it with your leg, it will automatically remain at that point because you've applied an external force to it. So we are going to look at some mathematical expression of what a force. Mathematical expression of a force. In books, you see they'll ask you questions, calculate the force of so and so. Yeah, calculate the mass if a force is being given to you and what acceleration due to gravity is being given to you. You calculate the force of what that body. Okay, a force is what? As you can see on your screen, force F. So anytime you see F at any place, it's what the force in this topic. Anytime you see F, we are referring to what force. Force equals what mass, which is m, times acceleration due to gravity. Times acceleration due to gravity. Sometimes this automatically hot weight because the acceleration due to gravity is there. But sometimes you see hot ma. So force is hot equal to hot ma. M over there is the mass, a is hot the acceleration. And acceleration also is having its own hot formula. Acceleration simply is the rate of change of hot velocity. If they say rate of change, anytime you hear rate in hot physics, that means we are referring to hot time. It's the time rate of change of hot velocity. So acceleration A over there, as you can see, is equal to V over hot T. A equals hot V over hot T. The A over there is acceleration. V over there is what your velocity, and the T over there is your time. So as a velocity over hot, the time represents your hot acceleration. But in some cases, you'll be given two velocities. Thus, you'll be given an initial velocity and hot, a final hot velocity. You'll be given initial velocity and hot, final velocity. If they say something is initial, that means that's the starting hot point. So initial velocity simply means starting hot velocity. Final velocity is what? The final velocity. That's what the end point, the velocity attained at what? The end of your journey. That the velocity attained at what? The end of your journey. So initial velocity simply means what? Your starting velocity. The final velocity simply means what? Your end hot velocity or your the end velocity. The velocity at the end of your journey or at the end of your movement. So initial velocity is represented by the symbol U. Final velocity is represented by the symbol V. So anytime you see V and U represent hot initial velocity, V represents hot final hot velocity. So if you want to relate all these three, that's the acceleration, initial velocity, final velocity, and time. Acceleration is simply hot the final velocity minus the initial velocity all over hot time. That's, you can see it on your screen, that's V minus U all over hot T. V minus U all over hot T. And I've explained the terms over there where V is hot the final velocity, U is your initial velocity, yeah, and T is hot your time. So if you want to include this in your force formula, force becomes mass times what? The final velocity minus the initial velocity all over what? Your time. All over your time.
Sir,
okay. Yeah.
Please, I want to ask, like, how does force affect the size of an object?
You said?
How force
Yeah.
affects the size of an object?
How force affects what? The size of an object.
Yes.
That's what I mentioned. Let's say you've deflated a balloon. There's no air in a balloon, right? Eh?
Yes, sir.
The force you are introducing into that balloon is the air you are introducing into it. You are applying an external force, which is the air. So what's going to happen? The balloon automatically increase. Is that not so? It will increase in
Yes, sir.
size. So force introduced into that hot balloon is what? Forces the dimension or the size of that hot balloon to increase. Okay. Another one is the deflated tire. Let's say there is no air in your car tire. You had hot puncture, there is no air. What's going to happen? That means there is no force or there is no air inside the tire. So what you have to do is you must send it to the organizer for them to pump air into it. Is that not so? Okay.
Yes,
The air introduced into the deflated tire becomes the force that's being introduced into the tire. So automatically you see that the tire comes back to its normal position. It increases in size. You get
Okay.
what I'm saying?
Yes, sir, I do.
Okay. And please mute yourself. And the unit for force is Newton. The unit for force is Newton, which is represented by capital N. Newton, capital N. And the unit for velocity, which is V, is meters per seconds. The unit for velocity is meters per second. That's m/s. Sometimes you see ms raised to the power -1. It's the same thing. Ms raised to the power -1 is the same thing. And the unit for acceleration, please don't forget to write your units. In physics, unit is very important. Without a unit, you will be marked wrong. So make sure anytime you finish your calculation, the units are attached to everything you do. Okay. Velocity over the V is meters per second, sorry. The velocity you have, the V equals meters per second. Acceleration A is meters per second square. Remember, acceleration is meters per second square. Velocity is meters per seconds. Note the 2. Okay. We have a question there which is being solved over there. So I'll take you through these questions. Then there is a trial question after this. Then I'll let you solve that one and give me the answers. I'll call you, then give me the answer. Or you raise your hand and give me the answer. Okay. So the first question over there, calculate the force acting on a body of mass. Calculate the force. Please make sure you have your calculator there. Calculate the force acting on a body of mass 50 kilogram. Moving with an acceleration of 30 meters per second square. Calculate the force acting on a body of mass 50 kilogram, moving with an acceleration of 30 meters per second square. You can see the solution over there. I've given you the force. No, I've not given you the force. That's what you are supposed to calculate. So the force wasn't given. You have to calculate the force over there acting on the body. And the mass over there was given to be 50 kilogram. 50 kilogram. Then acceleration was also given to be 30 meters per second square. 30 meters per second square. I've given you the formula. The force F is equal to the mass M times acceleration A. The force F is equal to the mass M times acceleration A. So what you are just going to do, I've given you the mass M and what the acceleration. The mass over there is 50, acceleration is 30. So you just multiply the two, you get an answer to be F equals what? 1,500 what? Newton. 1,500 Newton. 1,500 Newton. Okay. If you look at the second question, a body of mass 20 kilogram, a body of mass 20 kilogram moves with an initial velocity of 5 meters per second to a velocity of 15 meters per second with time interval 2 seconds. Calculate the force acted on the body, or acting on the body, sorry. Calculate the force acting on the body. It's not acted. Calculate the force acting on the body. So this one, we're given initial velocity. Initial velocity, that's the starting velocity. We're given the initial velocity, that's the starting velocity to be what? 5 meters per second. And we're given the final velocity. They said the initial velocity of what? 5 meters per second, 2. If you see 2, that means that is moving to what? That final velocity. So to a velocity of what? 15 meters per second. So that velocity becomes our what? Final velocity. That's the end velocity. So initial velocity becomes 5. The final velocity becomes what? 15. And as you can see in the solution, I've written my data down first. Anytime you are solving a physics question or any mathematics question, make sure you put your data down. So
Sir,
yeah.
in the question you wrote 15 as your final velocity, but in your
Okay, yeah.
computation you wrote 25.
Yeah, thank you very much. Thank you very much. Thank you very much. So, yeah. So it was a typing error. Yeah. So let's use the 15. Use the 15 and give me your answer. But I used 25 over there. The computation over there, I used what? 25 as my final. So you'll be using 15. If you use 15, give me the 15 answer. Use 15 as your final. But over here is what? 25 that I used over here. So my mass M over here is what? 20. Initial velocity is what? 5. My final velocity is what? 25. And the time over there is what? 2 seconds. We have to calculate for force. And we know that force is what? Mass times the final velocity minus the initial velocity all over what? The time. So you get what? F to be equal to what? 20 times the 25 minus the 5. The 5 over there is the initial all over what? 2, which is the time. And I got F to be what? 100 what? Newton. 100 Newton. So please use 15 as your final and raise your hand. Let me call you right now. Use 15 as your final. The question, yeah, the question you have, the question 2, you solve it. I use 25 as my final hot velocity. Yeah. Justin, Jamesi, yeah.
Sir, please, the answer is still 100 Newton.
The answer is still
100 Newton.
100 Newton.
Newton.
Okay. Why will it still be 100?
Sir, please, in the question, the
Okay.
final velocity is 15.
Wait. Yes.
And so here, let's refer to your question. Your question,
15 minus 5,
when
right?
Yes, please.
15 minus 5, which is what? 10.
10.
Divided by
Yes,
2,
please.
you get what?
Yes,
So
that
yours was
will be
100.
5.
So I think the computation
Yes,
over
please.
here is not supposed to be 100 Newton. My answer over here.
And it
I'm
should be 200.
Yeah, I was using the 15.
Yes,
Over
please.
here, it's a typing error.
It's
So
a typing error, yeah.
Yeah, over here is supposed to be 200 Newton.
200 Newton, yes.
Yeah.
I use the screenshot to do my profile.
So 100 Newton for the 15 is correct. Yeah. So Jamesi, you are correct, okay? Who else had the 100 Newton? Yeah, Vigno.
I also had it.
Okay.
Me too.
Me too.
Who is me too?
Me 3. Me
Hey,
4.
Hey. We are doing everything in order, please. Raise your hand, I call you. Okay. Then let's continue. I'll give you another one. Okay. Okay. This one is a different question. They said a body of mass 40 kilogram start from what? Rest. And rest means the body started from what? 0. Initial velocity is what? 0. Rest means there wasn't any motion at all. The body is what? At its what? Resting position. There is no motion. It's what? Immobile. So a body of mass 40 kilograms starts from what? Rest to a velocity of 20 meters per second in time interval of what? 5 seconds. Calculate the force on the body. Calculate the force on the body. So you can see that in my computation, I said note. Anytime a body starts from rest, initial velocity U is what? 0. Initial velocity is what? 0. And the final velocity is what? 20 meters per seconds. The mass over there, M, is what? 40 kilogram. And the time T is what? 5 seconds. We have to calculate for force. That's why the question mark is there. So we know that force equals what? Mass times what? Final velocity minus the initial velocity all over what? Time. So if you put all those figures inside, you are going to get, you'll get 160 hot Newton as your hot final answer. Because if you want to calculate for the acceleration, it's what? V minus U all over T. And the V over there is 20. Your U is what? 0, initial velocity, all over the time, which is what? 5. And if you multiply that with what? The 40, you get what? 160. Hey, please wait. So you get what? 160. Okay. So I'll be giving you some work right now. Hold on. Please, can you see horse on your screen? Hello?
Sir, yes, we can see.
Okay, so these are trial questions. Calculate and give me your answers. Let's see. The first one, a body of mass 100 kilogram moves with an initial velocity of 30 meters per second to a velocity of 70 meters per second in time interval of what? 10 seconds. calculate the force acting on the body. And the second question is, stone boy of mass 40 kilogram moves with a velocity of 70 meters per second. If a force of 100 Newton acted on him, calculate his what? Acceleration. And the third question, Sunrise school bus from a velocity of what? 5 meters per second to a velocity of 30 meters per second in time interval of 10 seconds. Okay, Sunrise school bus moves with a velocity. It's move, not from, okay? Sunrise school bus moves with a velocity of 5 meters per second to a velocity of 30 meters per second in time interval of 10 seconds. If a force of 50 Newton acted on it, calculate the mass of the bus. So try these 3 questions and give me the answers. If you are done, you raise your hand. Avugla, please wait. Please wait. I can see your hands up. Please wait. Make sure you solve all before you raise your hand up. Yeah. Make sure you solve all and you raise up your hand. Okay, I think time is up. Yes. The first answer, please. Yeah, Fiati. Fiati. Okay, I'll go to No.
Okay, sir.
Okay.
The first one, I had the force to be 400 Newton.
The first one. The force 400 Newton.
Yeah.
Let me listen to Fiati. Fiati, did you get the same thing?
Yes, please, sir.
400 hot Newton.
Newton.
Yeah. Okay. Who else? Hey, Jamesi.
Sir. Sir.
Yeah.
Please, I also had 400 Newton.
400 Newton. Okay, thank you.
Yes, sir.
Okay. Any other? Yes, Desmond. Desmond.
It also had 400.
400. Yeah, thank you.
Newton.
Okay. Okay.
So I had 300.
So if you had a 400 Newton, raise up your hand. Let me see. Okay. Okay. I can see your hands up. Yeah. That's good. Excellent. Yeah. Okay. Okay. Thank you very much. Okay. It's 400 Newton. What you just have to do is the mass was given. Please mute yourselves now. Mute yourself and lower your hands. Yeah. Hey, Desmond, mute yourself. So what you just have to do, those who didn't get a 400 Newton, the mass was given. I said force is what? Mass times what? The final velocity minus the initial velocity all over hot time. The mass was given. The initial velocity was given. Make sure you write your data down first. Your data will help you how to solve it. If the formula is there and the data is there, you just put hot your data into your formula, then you are off to go. So I said your force is hot, mass times or the final velocity minus the initial all over hot the time. If you compute this very well, you get hot the 400 Newton. Okay. Let's see the acceleration of stone ball. Yeah. Question 2. Question 2. Your answers, please. Question 2. Raise your hand if you have the answer. Question 2. Yes, Fiati.
Sir, please, I had my answer to be
You had what?
I had my answer to be 3.33.
3.33.
Meter per second.
3.33 meter per second. No, you are calculating for acceleration. So it's meters per second square. Meter per second square, yeah. So that's the unit for hot acceleration. It's not meter per second, okay?
Yes, please.
3.33. Okay, Desmond, I can see your hand up.
Okay, sir. Please add my answer to be 28 meters.
28. Okay. Who else? Who else? Fiati. Yeah. You say you have 3.33, right? Okay, mute yourself now. Who else? Jamesi.
Yeah.
Yeah, what's your answer?
Sir, please, question 2. I wasn't unable to solve it for
Why?
some reason. I think I got confused with the fact that they gave me just one velocity.
Yes, they can give you only one velocity.
Velocity. So does that mean that the initial velocity is 0?
Yeah, automatically. If one velocity is given to you, that means there's no initial.
Oh, okay.
Yeah.
Okay. Thank you, sir.
Okay.
Sir.
Yes.
I had 1.75.
1.75.
Yeah.
Yes, Eugene.
So I had 28 meters per second square.
You said you had what?
28 meters per second square.
28. Oh, okay. So, please copy the questions down. Okay. I'll inspect.
Okay.
And do the rest as assignments. I'll ask of it next time when we meet. So next week I'll ask you the answer you all have gotten. So the people that were not able to tell the answers.
Sir,
Yeah.
please, for the last one.
No, the second one. You people are mentioning different answers. So make sure you go to it again. Get your answers.
Okay, sir.
Let me know.
Okay.
All right. Thank you very much for your participation.